Good morning. Myself Prabha Ranche, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, we are going to discuss about the topic is discrete Fourier transform from the subject is digital signal processing. Let me see. First, we should know about why we are using DFT, discrete Fourier transform. The discrete Fourier transform is used to convert the time domain sequence to frequency domain sequence. Frequency domain information must be extracted, so we need to convert time domain to frequency domain. For that, we will use discrete Fourier transform DFT. Okay. For a discrete time sequence, we define two classes of Fourier transform. The discrete time Fourier transform for sequence having infinite duration, and the discrete Fourier transform for sequence having finite duration. Mathematical expression for DTFT is which is represented by capital X of omega, which is equal to summation n equal to minus infinite to infinite x of n e power minus j omega n. Same thing. Inverse DTFT mathematical expression for IDFT is x of n equal to 1 divided by 2 pi summation minus pi to pi x of omega e power j omega n into d omega n. This is the here you can see the graph time domain and frequency domain, and the DTFT represented by capital X of omega is periodic with period 2 pi. The frequency omega is the digital frequency, and therefore it is limited to interval to the interval minus pi to plus pi. The digital frequency omega is a normalized frequency relative to sampling frequency is defined as omega equal to 2 pi f divided by fs. Fs is represented by sampling frequency. Here you can see the both time domain and frequency domain of the DFT representation. Yeah, okay. In discrete Fourier transform, given a finite sequence, that is capital X equal to x of 0 and x of 1 and capital X of up to capital X of n minus 1. It's a discrete Fourier transform is a finite sequence which is represented by capital X of k equal to summation n equal to 0 to n minus 1 x of n w n of kn. Wn is represented as total factor. W of n equal to e power minus j 2 pi divided by n. Similarly, inverse discrete Fourier transform x of n equal to 1 divided by capital N, which is represented by length of the length of the sequence is represented by capital N. 1 divided by capital N summation k equal to 0 to n minus 1 x of k into w n of minus kn. W n equal to e power minus j 2 pi divided by capital N. Here you can see DFT and IDFT. The input of DFT is time domain sequence, and output of DFT is frequency domain sequence. The time domain sequence is represented by small x of n, and the frequency domain sequence is represented by capital X of k. Similarly, the input of IDFT is frequency domain sequence, that is capital X of k, and output of the IDFT is time domain sequence. Representation of discrete time Fourier transform and discrete Fourier transform. And the properties of discrete Fourier transform. There are more properties. First one is linearity and time shifting property, and frequency shifting property, time reversal property, conjugation and time convolution, frequency convolution. Time domain of linearity sequence is a into x1 of n. We know time domain means small x of a is represented by small x of n. There are two sequences. That means two sequences, x1 of n plus x2 of n, and a into x1 of n plus b into x2 of n. The time domain of the frequency domain of the time domain sequence x1 of k is represented by capital X1 of k and x2 of k. And the application of DFT, there are more application. First one is spectral analysis. DFT is used in image processing to image processing and signal processing. Second application is image processing, and third one is signal processing, and other application is sound filtering and data compression and partial differential equations and multiplication of large integers. And here you can see the difference between both DFT and IDFT. Okay, DFT is finite duration sequence, finite duration discrete frequency sequence that is obtained by sampling one period of FT. FT means Fourier transform. Okay, whereas IDFT is inverse discrete Fourier transform, which is used to calculate time domain representation form of capital X of k. Okay, we know input sequence of DFT is time domain and output sequence of DFT is frequency domain. Similarly, IDFT input sequence of IDFT is frequency domain, output sequence of IDFT is time domain. DFT equation are applicable to causal finite duration sequence. IDFT is used to basically to determine sample response of a filter for which we know only transfer functions. And already we know the formula, mathematical equation of DFT and mathematical equation of IDFT. These all are the main difference between both DFT and IDFT. Okay, if you have any doubt means you can ask me through the comment. We will see you in next video. Thank you.